Alright, the next thing we want to learn today is synthetic division. It's a shorthand method of dividing a polynomial by a linear binomial by using only the coefficients. Alright, notice this. You have to divide a polynomial by a linear binomial. Alright, using only coefficients. So it's a much quicker way of doing what we just did. For us to do this, there are some very important things we need to know. First, the polynomial must be written in standard form using coefficients and 0 for any missing terms, and the divisor must be in the form of x minus a. That's important. X minus a. Alright, let's look at this. Alright, here it's all written out. In the next slide or two, we're actually going to work them out so you can see what's going to happen individually. But let's get started with the basics. First thing you need to do, here's your dividend. Here is your divisor. We want to make sure the dividend is in standard form. It is. And what we want to do, we want to write the coefficients. So we got 2, 7, and 9. Now, up in this corner here, we want to write what a is. Alright, it should be in the form of x minus a. So basically that means whatever number you have here, change the sign, and that's what a is. So positive 2 becomes a negative 2. Alright, so now we've got it set up. You want to draw a bar underneath it and bring down the first term. So the first term is a 2, so bring that down. Alright, what you're going to do now, you're going to take this 2 here, multiply it by our a, so 2 times negative 2 gives us a negative 4 down here. Now we're going to just take and add these two. What is 7 minus 4? That gives me a 3. And I'm going to repeat the process. I'm going to take this 3 times the negative 2. That's going to give me a negative 6. 9 minus 6 gives me 3. Alright, now notice there's no more terms. And this last number down on the bottom's got a little box around it. That's because it is our remainder. Just like in our the long division, you put the remainder over the divisor. Now what do the 2 and 3 mean? Those are our coefficients for our polynomial. What you need to know is that this 3 would be times x to the 0 power, which is just 1. The 2 would be x to the first, and any numbers out in front of it, the x would continue to gain, a degree for each time you moved over towards the left. So 3 times x to the 0 is just 3. 2 times x to the first is just 2x. So we have 2x plus 3 over x plus 2. Alright, let's look at this again, up close and personal. Alright, here we go. 3x to the fourth minus x cubed plus 5x minus 1 divided by x plus 2. First thing we need to do, figure out what a is. I have x plus 2. We've got to make sure we swap the sign, so it should be, a should be negative 2. We got that. Next step, we got to make sure that the dividend is in standard form, and we got to write the coefficients. So here we go. 3x to the fourth, a negative 1x cubed. There's no x squared, so we got to use a 0, a 5x, and a negative 1. We're going to write the negative 2 out beside it because that's our a. Alright. Now, what are we going to do? You bring down the first coefficient, that's a 3. Now 3 times negative 2 gives me negative 6. Negative 1 minus 6, negative 7. Negative 7 times 2 gives me a positive 14. What is 0 plus 14? It's just 14. 14 times negative 2, negative 28. 5 minus 28 is a negative 23. Alright, last time. Negative 23 times negative 2 is 46. Negative 1 plus 46 is a 45. 45 is our remainder. So we're going to draw a box around it. Then after that, these numbers are our coefficients. We're going to start with x to the 0, x to the first, x squared, x cubed. Right. And that's exactly what we've got. Alright, now try this as you have time with this one down here. Alright, find your A. Make sure you write this in standard format using coefficients. And then do the same thing we've done every time here. If you've got questions, please ask me. I'll be glad to help. Alright, next thing we've got to go over is synthetic substitution. This is actually very easy because you're going to do the exact same thing that we just did with synthetic division. The thing about synthetic substitution is even though we work it the same way, the answer means something different. Alright, and that's going to be described here in the remainder theorem. Basically it says if the polynomial function p of x, so that's the polynomial, is divided by x minus a, like this one, x minus 3, then the remainder r is the p of a. Alright, let me put this in terms that are a lot simpler. Alright, if we divide this number, this polynomial, by x minus 3, then basically it's saying if we plug 3 in, we're going to get the remainder for an answer. So take whatever this is, that's what you plug in, you get it for the answer. Alright, now let's see what I'm talking about. Alright, use synthetic substitution to evaluate the polynomial for the given value. We're going to do this just like we did our synthetic division. Alright, we write the coefficients in standard form, 2, 5, negative 1, and 7, and we're going to use the number 2. Alright, work it out just the same. Bring the 2 down. 2 times 2 is 4. 5 plus 4 is 9. Times 2 again is 18. Negative 1 plus 18 is 17. Times 2 is 34. 7 plus 34 is 41. Alright, but this time the 41 is not a remainder. What the 41 tells us is if I plug a 2 into this equation, I get 41 for my answer. Alright, now let's check that out. If I plugged a 2 in for x, what do I get? 41. Alright, let's do this one more time, and hopefully you got it, and then we're done for the day. Alright, use synthetic substitution again to evaluate the polynomial for the given value. Alright, the p of x is x cubed plus 3x squared plus 4 for x equals negative 3. So what are we going to plug in? Negative 3. Alright, we've got to put our coefficients in standard form. Alright, 1, 3. There is no x, so there's a 0 there, and a 4. Alright, let's bring the 1 down. 1 times negative 3 is negative 3. 3 minus 3 is 0. 0 times 0 is 0. Alright, bring the 0 down again. 0 times negative 3 is 0. 4 plus 0 is 4. Alright, if we did this right, if I plug in a negative 3 in this equation, I should get 4 back. Let's